Hello everyone. Today we will make a special meeting with Dr. and Szydlo, and I think he will come soon.
Hello.
Hello.
Ferhat, a very, very good morning to you.
Good morning to you too. How are you?
Extremely well, thank you. Let me just see, because I've never done this before. So I just see if I could make maybe a larger screen. But if I can't, it doesn't matter. I've never done this before, maybe a few years ago.
Yeah, thanks.
But you could see me.
Yes.
Okay, and I could see you and I could hear. Now let me see. I should be looking up maybe at the screen there. Is that better there for you? Let me see if I can get a full screen. But I think that's fine. You can see me all right.
Yeah. Can you see?
I can see you very well.
Thank you. Thank you so much. By the way, I'm so sorry if I make any mistake in the conversation skills because of.
You must not be sorry at all. You must not be sorry at all. I will make mistakes as well, so you must not worry about my English. I gave a talk, a Zoom meeting to some students from Boğaziçi University 4 years ago, and I learned a few bits of Turkish, which I have forgotten, but it was in the evening. So I said, "İyi akşamlar." Does that mean good evening? And then I said, I think I said two other phrases. One of them was to say something like, "Thank you for inviting me." And the second one was, "Thank you for listening to me." So one of them was, "Davetiniz için teşekkürler." And the other one was, "İlginiz için teşekkürler." But I can't remember which was which. So you've seen my bad Turkish. I will now listen to you. I will be very happy.
No. And also, first of all, I'd like to thank you for accepting my meeting.
Pleasure.
And also, I watched that video on YouTube, and its your explanations are very important for us. And also, we learned different things about chemistry and expressing chemistry to the students and stuff like that.
Yes, I'm very pleased.
And also, I read your articles about different area, and also very powerful articles for me. And I learned lots of different things.
I'm very pleased because I write them for the whole world because there is a lack of understanding of many ideas, especially historical ideas. I think that chemistry, all sciences should be taught with a historical perspective.
Yes.
And that's what I highlighted in those articles.
Yeah, and also you are expert on the history of the alchemy, right?
Well, I'm not the expert. I am. It's a field which I find very interesting, and I did my PhD in that field. I did my PhD in history and philosophy of science at University College London, and And so but I'm by no means an expert. There are people who are far better. I am a school teacher, you must remember.
Yeah, I know that. And also, just a second, I want to look at my notes. And
Yes,
also,
please.
you graduated from the chemical engineering department,
Yes.
and then 53 years chemistry teaching in a one
Correct.
school. This is
Yes.
very
No,
important situation.
I did 2 years at Cardinal Manning School.
Yeah.
This is my 51st year. So I did 2 years in another school. And I have now been teaching for 51 years at Highgate School. But I no longer do classroom teaching. For the last 7 years, I have been doing only outreach teaching. So that means I visit other schools. And I have this year, I will have given 97 lectures in other schools around in the United Kingdom primarily, but quite a few in Poland as well.
Yeah, Mr. Szydlo, I watched all of the video on YouTube, and also like you, I want to make this situation in my country by using a different, yes. Therefore, I want to make a meeting with you. What kind of advices can you give for this situation?
Right. So the first thing is to show chemistry is to, first of all, is to, for people, for young, whoever you address to, they must know what chemistry is. Because one of the things that is missing from the education programs is to define chemistry. Everyone knows what biology is, the science of living things. Astronomy, the science of the stars, the planets, the heavenly bodies. Physics, more difficult. I describe it as the science of matter and energy. Chemistry, even more difficult, the science of substances and how they turn into different substances. So that's a definition which I've always given. Now you can argue, you can say, oh, but there must be a starting point. Now, in that context, everything which you do is understood as changing from one thing to another. Now, in any chemistry presentation which you do for young people or for older or for the public, it is you have different kinds of chemical change. And for me, every chemical lecture, doesn't matter what the subject is, should involve color changes, flames, explosions, sound effects, smoke. All of those. If you don't have those, then your chemistry lecture will not galvanize an audience. And I always make sure that in those, and chemistry is very easy because you can find so many chemical reactions which demonstrate all of those phenomena. So, for instance, when I gave the talk to wonderful students from Boğaziçi University, this was during lockdown. I did it in front of this TV here on a ironing board, and I showed them loads of experiments. You do experiments anywhere, and that's the important thing. But to do those experiments and to do them safely, you must have the knowledge, obviously. So that's probably, that is one field where you have to have, and you also must practice. You can't do an experiment in front of an audience without practicing it. Now, I'm very lucky because at Highgate School, we have got fantastic laboratories. Do you have laboratories? Okay, so that's
in my home.
Yes.
I'm so sorry. In my home, I have a small laboratory and also different ingredients such as sulfuric acid, nitric acid, and stuff like that. I'm making a different experiments.
Very, very good. So there are very, very few people or teachers like yourself and myself that are passionate about chemistry. So we like doing experiments. We like trying out reactions. And this is so important. When they changed the syllabus about in 1986 in England and throughout the world, much of the old teaching methodology was removed, and they removed many experiments as well. Well, they removed some of the best experiments. So I start showing these again. I have been showing them. I show them at all my lectures where I give them in schools or at institutions, universities. But it's not my choice to organize the program. That's the choice of politicians, educationalists, and so forth. But as a chemistry teacher, I feel it is my obligation to show people what the science of chemistry is about. And
you're right.
It's the best science to lend itself for experiments, you see. You cannot, it's the best, if you're a chemistry teacher, that's the best thing you could be.
Yeah.
No.
And also, I think if I make this type of experiments to the audience or to the pupils or in other people, and also we can catch their attention to this science. And also chemistry is very important science, and also everything is chemistry, and also all of us are produce atoms and stuff like that, you know that? Therefore, this science, not the biology, not physics, not mathematics, chemistry is so important for us. And also we can produce all of the information, all of the ingredients by using the chemical reactions. This is the basic situation, you know.
You have exactly said the correct thing. And you see, when I give talks wherever, I always stress exactly this point, that we use chemistry every day. And you know, one of the most important things that the chemists have achieved is to give us pure water from the tap. You drink water, but you don't know where's it. Well, the chemists have purified it. And I consider us very lucky that we can have water, because many people don't have water which has been purified by the chemists. And that's just a starting point. But then, as you said, everything that we use around, paints, varnishes, glues, adhesives, fertilizers, fuels, masses of things, that is all the same. So that's why I think it's a very good subject to be teaching.
Yeah. And
it is very important, I find, to stress the dignity of chemistry. It is a dignified science, and it is a science with an ancient history which goes back to the roots of humanity. It was for many thousands of years, the chemical art was an art, it was a craft. In ancient Egypt, they used to make glass, ceramics, soap, wine, bread. All of those are chemical processes, but they were in the context of an art. It was necessary. There was no exact measurements. The modern chemistry that we have today has evolved in the last 250 years. That's what I always say to children. You can say it evolved since Lavoisier, since the theory of combustion of Lavoisier, the atomic theory of John Dalton. That's what the modern quantitative chemistry. And I always stress this to the more advanced students. But the important thing I stress is every human being, all human races, we are all together. We have created the science. In different parts of civilization, in different parts of history, different people. And I always stress, very important for people to understand, that people who lived hundreds of thousands of years ago were at least as intelligent as we today. They were very intelligent. And we owe our chemistry, everything we have today, to generations of unbelievably intelligent people who have given us what we have today. It is a great mistake. One of the great mistakes today is to think that we're cleverer than other people. That is one of the greatest problems, is today's arrogance, that we think we know so much. We do know so much, and we are clever, and our scientists are brilliant, but we must not forget that this is part of humanity. And people who lived, the earliest ancestors of the human race, which I believe were in East Africa, that's what I have read, and they were at least as intelligent as today's. And so it's very important to stress the dignity of the science, our achievement, and also to emphasize to value what we have achieved. In today's world, people are taught in the education programs not to have the value. They pass examinations in chemistry. You know that. They pass examinations in chemistry, but they have very limited knowledge. They just learned to pass the exam. So and all the people, I meet many wonderful teachers like yourself who understand that the chemistry is more than just passing an exam.
And
it's
also
a experience.
And you are exactly right. And also in my country, generally, most of the students say, teacher, why we are learning this type of information, and also what type of situation provides in our life and stuff like that. This is meaningless, but the most important situation, what is the chemistry? First of all, they want to understand these type of basic information and backgrounds.
This is the whole world has gone like this now. The chemistry education throughout the whole world has declined in the last 50 years. I've watched it because I was taught in the old system where you had a huge amount of information to gather, etc., etc. I have written about this in my articles, of course. And you know, I have wonderful students in my own school who want to learn more. They know their program is limited. So, for instance, this year I have been focusing on what used to be on our A-level syllabus, and that's the chemistry of the group 4 elements: carbon, silicon, germanium, tin, and lead. And we have been doing experiments with compounds, with the chemistry of these, because there's a wonderful graduation from non-metallic to metallic properties and oxidation numbers. And today they learn a little bit about carbon dioxide. They learn virtually nothing about carbon monoxide except that it's a poison. They just learn fragments. I am having today a special meeting I have a chemistry society, and I'm demonstrating for them the chemistry of acetylene. Now that's no longer on the school program. No one does acetylene anymore. But
in our country, for example, mercury and its compounds, and also most of the explosion experiments are forbidden. But we have to express these information by using the little bit active ingredients and stuff like that. We can do in a special laboratory. Of course, this is important situation, and also this should be forbidden for the public. But in the laboratory, we can do.
Of course, Well, you've hit the nail on the head, you see, because mercury is my next topic. I'm currently actually I've made a YouTube on the it's called Magical Mercury. I think I made a video for a conference last.
I watched that.
I watched. Now I'm writing an article at the moment which is entitled Magical Mercury. And in this article, and you know, in my school, we've done experiments with the chemistry of mercury. We have few cupboards, we have the equipment. No one has had any injuries. I haven't disposed of it anywhere. I've got all the mercury, I've kept it all. And it's as you said, it's entirely possible. But there are fewer and fewer teachers who know about this. And that's the problem, because I'm still part of the old generation, but I meet wonderful young people like yourself and teachers around the world, because I travel around. I've been to Mauritius several times. I've been to Namibia, and I have visited communities as well. So I do meet fantastic teachers. So I think it's very important that we carry this on. You see, one of the problems with mercury, benzene, phosphorus, they've been demonized. They've been demonized by the media. But it's not, you can't demonize a compound. You demonize the people who misuse it. That's a misunderstanding.
Yes, that's right. That's exactly right. And also, of course, if you put white phosphorus and with potassium chloride, of course, there is an explosion. This is basic chemistry. But if we can do these experiments in a small amount, in a special laboratory, this is.
And that's what I continue to do these, you see, and you've hit the nail on the head. It's doing it the right amount for wherever you are. Yeah. So if you're in a small room in the kitchen at a laboratory, then you get smaller and smaller. But on a large open space, you do it larger. And that's so important, is to, when you, and always another very, very important thing, which I also think is, when you do an experiment, it is very important to explain all aspects of the experiment. Yeah. So for instance, an experiment which I've demonstrated and which I'll probably be showing in a short while to some older students, is the preparation of sulfur dioxide from copper and concentrated sulfuric acid. Now that used to be a standard laboratory preparation, the preparation and properties of sulfur dioxide from copper and concentrated sulfuric acid. Now, I visited a school, a very, very top school in England about 5 years ago, and I went to the laboratories and I said to a school with a great tradition in chemistry, and I said to the teacher, do you demonstrate the reaction? I said, no, sulfur dioxide's too dangerous. Well, you see, that's the attitude.
Meaningless.
Yeah, of course. And if you ask today, as I have done, a pupil who was just 18 years old, just finished their exams, what do you know about sulfur dioxide? The only thing they know is that it causes acid rain. And they will know the equations. So I say to you, is acid rain good or bad? They say acid rain is bad. So then I say, does that mean that what you know about sulfur dioxide is it is bad? And they say, yes, that's all we know. That's how children are taught today. They're not taught the chemistry, the interesting, what there should be is the redox chemistry, the acid-base chemistry. They're taught whether it's good or bad. That's a very, very big mistake in today's education. Going back to that reaction with concentrated sulfuric acid and copper, which I've described in detail in my article on sulfur, The Extraordinary World of Sulfur, Part 1. In the olden days, this was the mistake they used to make as well. They focused on the sulfur dioxide, but not what was left behind in the flask. So what happens to the copper, right? So you'd think that copper and sulfuric acid should make copper sulfate, but then it's a redox reaction. So copper sulfate, but it's an acid as well. But so if you've got copper sulfate, it should be blue, but it's not. The product is black. So when you look at the product black, you then look up in the books and they tell you it's copper oxide. But it can't be copper oxide if it's in sulfuric acid, because it will make copper sulfate. Now, I spent a lot of time reading that, and in fact, it turns out it's copper sulfide. So I thought, well, copper sulfide, that should react with an acid to make H2S. It should stink of hydrogen sulfide. And besides, how do you go that low? Well, once you go into the literature, it turns out that copper sulfide is inert. It doesn't react. It's got a very hard, I think it's a giant covalent lattice. It's probably similar to something like silicon dioxide, and it's unreactive. And that is, in fact, what is made. It's copper sulfide. And I've written about this in this article, but then some people may find, so it's so important when you conduct an experiment with children is to analyze everything, not just the main product. Another one is acetylene. Today, I'll be demonstrating, I've made a new film, by the way. It's going to be shown at an international conference on August the 8th. Professor Ramasalbi of Mauritius has organized this, you see. And it's about 190 papers are read at this conference. It's called VCCA 25. They've been doing this for many years, 190 papers, and I'm one of the keynote presentations, and that would be the chemistry of acetylene. So if you want to find out, it's all available to anyone.
Thank you.
See, when you make acetylene, C2H2, it's very important to analyze what the calcium carbide has become, because you make it from calcium carbide and water. But the important thing is to show that the product is calcium hydroxide. So you put universal indicator in, and then you can discuss. And in that way, the student has a complete image of what is going on. It's to analyze every aspect of the reaction, and not just see what you're trying to produce. The main product, which is acetylene in this particular case. So yes, the thorough and detailed analysis of every experiment. The other issue, of course, when you present for children is for what age group do you say what, right?
Yeah.
So, I had 3 weeks ago, I had my greatest achievement for presenting chemistry to people. Do you know what my achievement was? I was asked to give a talk for 5-year-old children, 30 children aged 5 years old on chemistry, right? And do you know what? Half an hour, but you have to use the right language. You have to say to the children. So when you mix, for instance, 2 colors, you mix together lead nitrate and potassium iodide, and you get bright yellow lead iodide. You say to the children, what color is it? And they go, yellow. And then you mix the next 2 and they say red. And you see, this is the language for the children. You have to, and I could show the same experiments at Sheffield University, where I visit the students every year, and I will explain to them that, these are a very low solubility product of lead iodide. I can talk to them about the redissolving of mercury iodide to form the complex ion HgI4 2- or whatever it is, by adding extra iodide. So I'm showing them the same effect, but at the university level, you go into the history of it as well. So I could use the same experiments for a variety of different settings. And this
by the way,
that's it.
And by the way, Mr. Szydlo, and your explanation ability is so powerful and attractive. And also, especially, I like potassium permanganate, aspirin, and the cough syrup.
Yes, well,
it's a very good explanation.
Well, do you know what? I regularly show this because it's a spontaneous combustion.
Yeah.
But I now always, since the last few months or maybe the last year, I've always been telling children that the man who demonstrated this was a liar, and he was tricking people into buying his medicine. And I say this, and I say that the aspirin has nothing to do with, and I explain this to the children, and I say the reason why is because today nothing has changed. There are still people trying to, the people will trick you not with medicines, but by scamming on the internet, people on the street, free, so-called free gifts. There's no such thing as a free gift in life. Nothing is free. And I explain this to the children, and I say the best way to protect yourself is to learn and have your self-respect and dignity. And that always, it's so I've now started explaining the experiment. Now, it was very fortunate that in my case, this sparked my enthusiasm for chemistry because it was a spontaneous combustion. So I thought this was amazing. And the story which I tell it's not exactly true, but most of it is true. And that's what sparked my interest, was the idea of a spontaneous combustion. That's another type of effect, which in chemistry is very spectacular. And I demonstrate this, for instance, with the reaction with concentrated sulfuric acid on potassium chlorate and sugar. That gives you a spontaneous reaction. So I have the whole range of these experiments, and I'm also continuously trying to invent new topics. So as I said, the mercury topic, I taught that by the way, about 10 years ago, before I finished full-time teaching. I gave a special lesson to my class on the chemistry of mercury. They were 14-year-old students. But you see, today, if you want to do a lesson on something different, then you'll have pupils saying, "Sir, that's not on the syllabus. You have a different."
I think, yeah, you're right. And also, I think the most important problem is the cost of the mercury. It's highly expensive.
Yes. Well, the thing is, you see, I know that mercury is banned in many places. So in Mauritius, when I went to Mauritius, they said they can't have any mercury compounds, which is ridiculous because it's, as you said, you're taking away an important teaching aid, and we're professionals. I'm a professional. I'm not someone who's messing around. Mercury, we have lots of mercury still here because we kept it for experimental purposes, and no one comes around to check to see when you throw your mercury away, because people know deep down that it's very important for education.
Yeah.
So
normally,
carry on.
Yeah, if you want, we can touch the mercury. There is no problem. If we exposure time by time, this is bad situation.
Yeah. But mercury compounds you can buy in England, but you have to have the special license, And so I think in England, we are still lucky that we can buy most substances for educational use, but you have to sign it off, which is fine.
You're right. And your explanations are so important for us. And also in your country, you have a real society. And also you are expressing these, you are making these experiments in the Royal Society, right? And also
the Royal Institution, the Royal
Institution. Sorry.
The Royal Institution, yes, they very warmly support what I'm doing. Maybe and the reason is, carry on.
Yeah, sorry. I'm so sorry. And also maybe I can make this type of institution in my country. Why not? And also I can express and make these experiments to audience and stuff like that.
Of course. And the important thing is with all the experiments and all the programs which I give is to have a theme for your talk, a topic. So, I have had various topics and use the experiments above all for educational and to explanation. And that's the essence. And sometimes some teachers, they do experiments just to make it look fun. But if you don't explain it, there's no educational value, very limited educational value. So for me, always is the most important thing is to give the fundamental explanation of what's going on.
By the way, Mr. Szydlo, and we have a 5 minute. You know that 40 minute is given by the Zoom. I don't understand this situation, but we have a 40 minute, and sometime after the 5 minute later, directly it can be closed.
That's okay. That's no problem.
I'm so sorry.
We can meet again. We can meet again if necessary.
And also, you want to give another explanation or another advice for the teacher? Do you want?
For teachers, do you know what? I think one of the most important things for teachers is to have empathy with your pupils. So if you have a class of pupils and some of them are a little bit naughty or some of them are not listening, you have to be able to exert discipline, have self-respect for yourself, but at the same time to make them interested. So it's not easy having an empathy for the pupils. I'm a very strict teacher. Okay, but my pupils will not say I'm strict because.
By the way, you are not strict, but you are. I think you are not strict. Yes. Your explanation is very attractive.
Yes, I know, but not all children want to listen, you see. And regularly, if I have an audience of 200 children, the most difficult age groups are 12, 13, 14.
Yes, you're right. Yeah.
That's, and then the adolescents. And then they don't see, I give talks for 200 children in a school. Not everyone is interested. That's fair enough. But then the teachers know that they mustn't eat chewing gum. The teachers know that they must not talk among themselves. And if they, and I do see children eating chewing gum, I would say, excuse me, do you mind not eating chewing gum because I can't concentrate? I say to the children, the experiments are difficult. And if you don't want to watch, then I'll ask you to leave. And I have occasionally asked students to leave. And the teachers will always support that because it's culture, it's good manners and culture. So I think empathy, understanding your pupils, your audience, whoever they are, whether they are 5-year-old pupils or university students, it's to talk at their level and to also have your own personal humility. That is always very, very important, is just say, look, I'm doing my best. Sometimes experiments don't work, and they usually do, but sometimes then you explain science, it's not that easy. And to prepare these experiments, it requires a lot of practice.
And the last question is, what is your favorite compound or element making experiments and stuff like that?
I'll tell you what, I think I've made a short film, I've made a film, and I think one of them is potassium permanganate.
Yeah.
The reason is that potassium permanganate is eminently suitable for a wide variety of redox chemistry, spontaneous combustion with the glycerol, plus its intense color is used for quantitative analysis in burettes and stuff. So I think potassium permanganate is a wonderfully universal subject for teaching chemistry. Michael Faraday, he used the candle. Michael Faraday, one of the greatest teachers, greatest scientists of all time, he used the candle as the one experiment, the candle flame, to build the whole of chemistry around it. And you can take one substance and derive a massive amount of chemical principles from one substance. I think potassium permanganate is definitely one of my favorites.
And for me, zinc sulfide synthesis.
Okay.
Highly powerful,
That's the one with the big explosion, yes.
Yeah, big explosion.
I've written that up in my article on sulfur experiment one day with a photograph.
By the way, Mr. Szydlo, thank you for expressing these very valuable information for us.
It's a great pleasure. It's an honor for me.
Yeah.
I very much hope we meet again.
I hope so. We will meet again. Sorry.
Thank you so much.
Sometimes I can not hear your voice because of the internet situation.
Yes. Right. Okay.
Sorry, by the way.
I hope we meet, and I hope one day maybe we shall meet in person. This will be even greater honor for me.
Thank you.
Thank you so much for your kind invitation, Ferhat, and we look forward to our continued contact.
Thank you so much. Thank you so much, Mr.
Very, very best wishes.
And also, I will send a special email after this conversation.
That will
can see.
No problem at all. It's a great privilege for me.
Thank you so much.
Very best wishes. Right.
Thank you.
Goodbye.
For you too. Goodbye.
Thank you. Bye-bye then. Thank you. Right. Let's see how we can switch this off. I'm not sure how. You switch it off. But I'll find where leave. Here it is. Okay. Bye-bye then.
Bye-bye. See you.